So today we are going to get into chapter 8 of our textbooks and begin by talking about the basic rules of dimensioning. And we're going to cover both basic ANSI rules and also how to do things in AutoCAD. Several of you have dimensioned in AutoCAD before, so some of this will be a review, and some of you have also learned the rules of dimensioning as well. I do want to point out that in this class I'm very particular, so when I'm talking about dimensioning and I give you the dimensioning rules, anything that's not following those rules will be counted off. So when talking about spacing, anything like that, we want to adhere to those rules in this class. Some of the other classes, like the AutoCAD classes, I'm a little more lenient on because we're really just learning the software. But in here, I'm going to be the CAD manager. I'm giving you the CAD standards, and you guys need to follow them. Okay? So let me... Don't ask me again. Okay. So I'm not going to cover everything in Chapter 8. In fact, I've got about 4 or 5 different presentations that I'll do, different chunks that cover more types of dimensioning. But to start with today, just on the standards that we use, we are using, you guys have seen this already in our template, the American National Standards Institute, the ANSI standard. So most of the rules that I talk about today will be from the ANSI standard. There's also the Society of Mechanical Engineers, there's military standards, and then there's ISO. We've seen the ISO standards, which is our metric. Now, we've been doing some metric drawings. We haven't necessarily followed everything about the ISO standards. For example, they use a different projection technique, first angle versus third angle, but we're not going to worry about that right now. But we're going to pretty much dimension it the same way, whether it's a metric or an English unit drawing. So when placing dimensions, we got to locate things, but then also size them as well. So in this case, we've got a hole in this feature, or it could be a cylinder sticking out, but we're going to locate its center as well as the size of the shape and the size of the shape itself, in this case a hole. I can tell that this is a hole and not a positive cylinder sticking out by the way it is dimensioned. So we'll talk about that more in just a second. So to show it all completely, we want to show all of our dimensions, again, sizes and locations. Also notice that the locations are called out before the sizes to avoid overlapping the dimension lines. So it's something we never want to do. So we always put our small dimensions first, followed by the larger ones. The dimensioning themselves, as far as how the text is read, they can be unidirectional, where everything's read from the bottom, which is typically what the ANSI standard is and what our dimensions will do. Now that's going to be driven by your dimension style that's already set up in the template, so you won't really have to do anything to get that to happen. You could also have a line where they read from the bottom or the side. You typically see that more in architectural drawings, so we won't have any like that. Again, that's just controlled by our dimension style. 2 different types of dimensioning that we might run into are some baseline dimensions and then some continuous dimensions. So with baseline dimensions, everything's being dimensioned off of what we call a datum. So a datum is an important feature that everything is measured off of. And as you can see, the left side and the bottom of this particular part are datums. Alternatively, we might do chain or continuous dimensions, where again they just run side to side. Now, there's a bit of a problem with chain dimensions, and that is a tolerance accumulation issue, or over-tolerancing. So I'll show you what I mean here. And instead of doing this slide, I'm going to switch over to AutoCAD here. And here's one of the parts that you guys drew earlier this semester. And I'm going to do a little bit of dimensioning here on this top view. So I can see that's a 1. Now I'm not properly spacing these. I'm just going to throw them up here real quick. That's a 1. So is that one. So there's a chain of dimensions. And then we typically need an overall dimension as well, because we're going to start by creating the overall part. So in this case, I get a 3. Now if I look down at my title block, because we cannot machine things absolutely perfectly, there's always going to be some tolerancing for either human error or machine error. And the title block will typically tell you what that allowance is, what is allowable. Now sometimes these will be tacked onto the dimensions, And we're going to do more of that in the next section or two, but not today. But if they're not attached to the dimensions, then the default tolerances apply. So as I look at this one, it says that if it's to 1 decimal place, it's plus or minus a tenth. So that means that this dimension right here, oh, I'm sorry, I got 2 decimal places. Let's see what 2 decimal places says. Plus or minus 3/100. So that means that this one can be anywhere from 0.97 to 1.03. Change this to a different text style here. There we go. So that's true for all 3 of those dimensions. So does that make sense? So with the tolerancing, again, my AutoCAD's going a little slow. Because we can't be perfect, as long as this part is somewhere between 0.97 and 1.03, it's still a good part. Now, if we took that the high end, the 1.03, and just copy this over and get rid of the extra here. In fact, I'm going to erase this. So let's say for the sake of argument, these all ended up being 1.03. Those are still allowable values, right? They're between the 0.97 and 1.03. But when I look at this overall value, it also falls into the same area of plus or minus 0.03. So that means this one can be anywhere from 2.97 to 3.03. They don't add up, right? It's not possible. These 3 add up to 3.09. It's not possible because we're going to cut the overall part out first, which is 3.03. So there's not enough room for all this to be true. So the way that you fix this is when you do a chain of dimensions, you leave one out. So maybe based on the way I cut, maybe I'm going to come over from the left 1 inch and cut here, and maybe from the right 1 inch and cut here, which means I'm going to be measuring this value and this value, which means I'm going to leave that one out. Or maybe, if you think about a table saw, how it has a fence and you measure everything off of that, maybe the left side's the datum and everything is measured off of there. So instead, I'm going to leave that dimension off. So it really depends on how it's going to be manufactured, and that's why we require a machining class, just to get an idea of how some things are made for the machine drafting majors anyways. But that helps determine what dimensions we want to leave on there. But more importantly, we want to leave one off. Does that make sense why? Okay. If we're talking about baseline dimensions, though, the advantage of a baseline dimension is that you don't have that issue. So if the left side's the datum, everything's measured off of the left side, then I can create my baseline dimensions all coming from the left side. There's no buildup of tolerance. So this could be 0.97 to 1.03, 1.97 to 2.03, etc. And we're good. So that's one of the advantages of the baseline dimension, is you don't run into that problem. All right. Let's switch back here. Okay, and again, that's all these slides are showing. They're showing a plus or minus 0.1. But same concept as what we talked about, and again, we just leave one out. So just some general terms. A detailed drawing is a drawing that's going to give us everything that we need to manufacture a part. So any specifications, any views that are necessary, and then any dimensions that are necessary as well. And I mentioned specifications, but anything special about it, it could be the material, it could be any processes like heat treatment for hardness, that sort of thing as well. And then again, the dimensions, as we've been mentioning. Talked about size and location dimensions. The parts of the dimensions themselves, so you have the dimension lines that the text is actually sitting in, and then you have the extension lines that are extending from the part, and then you have the arrowheads. There should always be a gap between your extension lines and the object. You do not want those to overlap. So again, that's something that you'll be counted off for, because it looks like it's one continuous line at that point. Now the good news is, when we draw, we do different line weights. So for those of you that have done a hand drafting class before, we draw the object lines thicker than dimension lines and center lines and so on. Now, AutoCAD's going to do that for us by layer. So you need to make sure your dimensions are in the dimension layer, and they will print thinner. So you have a little bit of differentiation between those, but we still want to make sure we have those gaps in there. And as you can see, it's about 2 millimeters. When you're talking about leaders, these could be call-outs for notes. They could be your diameter or your radius tools. We want them to be inclined roughly 20 to 70 degrees from horizontal. So what I mean by that is, and I'm not going to go in and actually measure and see if you're in that sweet spot or anything like that, but when using the diameter tool, for example, we want to avoid a very vertical leader or a very horizontal leader, because then they start to look a little bit like geometry lines. So somewhere between 20-ish and 70-ish is the sweet spot. Usually try to avoid running through corners, that sort of thing, just to make things a little more clear. When you are calling out a full circle, you use a diameter. When you're calling out an arc, you use the radius tool. Now, depending on the dimension style in AutoCAD, it might create a little extension line. It might go to the inside, the outside. So that's all controlled by dimension style. And then, as you can see, it also places its center point in there too. Now, again, I should really be going to the dimension layer first so that it's coming in at the different color. But then also, if I look at my layer properties manager, you can see that my object lines are set to 0.7 millimeters and my dimension lines are 0.18. So much thinner line weight when I'm using that layer. So I mentioned datums. Again, those are when we're doing our baseline dimensions, where all the dimensions are coming from. In a couple of weeks, we're going to get into geometric dimensioning and tolerancing, and we'll actually call datums out, and then dimensions will reference those datums. So that'll get a lot more important a little bit later, but just a general idea that, especially for baseline dimensions, is what we're dealing with. And then any general notes, again, kind of like specifications. So if I have a lot of rounds, you guys see these on drawings all the time. Instead of calling out every single one with the radius tool, we can put in a general note, save a lot of space and time. And then again, any other local notes for that particular part. So let's talk about the contour rule for dimensioning. And the contour rule of dimensioning basically states that the best dimension is where you can see the contours, where you can see the shape itself. So let me relate that to, let's say this here right here. And got a lot of hidden lines on this one, so I'm not crazy about this one. Actually, yeah, let's talk about this top square feature. So if I want to dimension this little square piece that pops out, this would be my width, and this would be the depth of it. So it's 1 by 1, this little square piece that sticks up. Now, I can also get the 1 by 1 dimension up here, but this is a better dimension. You see the contour, you see the shape a lot better in these two views. That is better than dimensioning it up here. The most important thing, and this is coming up on a slide, is that we don't dimension to hidden features. So the good news is this is going to visible lines. It's not terrible, but this makes a much better dimension since you can see the shape better. So does that make sense what I mean on that one? Okay. And you can see that on this little example here, this kind of stair step shape. The view where you can actually see the stairs is a better place to dimension than up here where it's just all flat. For organizing your dimensions, again, you want to go with the shorter dimensions first so that you don't overlap. If we're doing an English unit drawing, then the first dimension should be 1/2 inch away from the part, and then each one after that should be 3/8 or 0.375 away. And as you can see, if it's a metric one, it's 10 millimeters and 8 millimeters is the values that we'll use. So let's talk about that functionally in AutoCAD here real quick, if it will let me. Okay. So I'm going to go back to my baseline dimension idea on this one. So as I said, the first dimension needs to be a 1/2 inch off, and I have sometimes success tracking off of the part, and sometimes it goofs up on me, so we'll see what happens. So as I'm coming to place this one, I'm just going to track off of the midpoint, drag away from it, and go 0.5. And this is now 1/2 inch away from it. So if I go ahead and do my next one then, from here to here, depending on what I want to track off of, it's going to be 3/8 away from this previous one, so I could track off of its little endpoint and come down 0.375 from there. And then my last dimension, all the way across, and I totally missed, so I'm going to try that again. So we'll track off of this one and again come down another 0.375. So those are properly spaced dimensions. Now sometimes, especially if we're going out to the side, you might end up with some values that are close to the lines. I'm going to, let me see if I can give you an example over here. I'm going to do, let's just say from here to here, and then I'm going to track off of that. And by the way, it needs to be a 1/2 inch away from the outermost point. So 1/2 inch from this one, not that surface. So I'm going to see if I can track off of it. 0.5, good. And then I'll do another one. Again, I'll track off and go 0.37. So this one's not too bad. Of course, when I want something to look bad, it won't. And again, I'm going to track off of this one since it's the outermost spot. Oh, I only went 3/8 from there. So sometimes another thing that I'll do is I'll actually place it and then move it. So I'll make this dimension and I'll actually snap to this one. And then I'll grab its grip and then bring it out another 0.375. Now this actually looks pretty good, but sometimes you might find that you might need to grab the text itself and move it up or down or left or right to further pull things apart and have them look better. Another way that I'll commonly do the lines here, you guys that have had me before know that I'm crazy about offsets. A lot of times I'll just create some offset lines. So offset 0.5, offset 0.375, and then now when I dimension, then I could just snap to this line. And I know I'm dimensioning a little different this time around, but now I can just snap to these construction lines and erase them, and I've got all the spacing that I need. Again, you can grab these grips and move them around if need be. So you can try out either way as long as your spacing is the same. Another thing too is as you're going from view to view, you can snap to the previous ones. I don't have such an example right now, but let me show you one real quick. So let's say that I was dimensioning here to here, and I came off 0.5. Then when I'm dimensioning this one over here, I can just snap to the end point of that one to line them up. So for proper dimensions, we want to be specific, of course. We don't want things to be confusing, and that's one of the reasons why we don't cross dimension lines. And then the other thing is we do not repeat dimensions. We do not over dimension. So if I've dimensioned it in one spot, I do not want to dimension it elsewhere. So for example, here's the depth of 2 of this part. I do not want to also come up here and put the same dimension up here. It's over dimensioning. So the goal of dimensioning is to do just enough that the part can be built, not a bunch of extra stuff. Now sometimes things are a little confusing and extra dimensions help, and so that's situational, but as a general ANSI standard, we don't want to repeat any dimensions. As I mentioned a moment ago, we dimension to visible lines, not hidden lines. And we dimension to true shape views, not oblique views. So that's the big reason why we did some auxiliary views the last week or two. We got to create auxiliary views to dimension certain shapes. And then we want to place dimensions outside of the part unless it can't be avoided. So for example, back in AutoCAD, if I am dimensioning the diameter of this hole, I really don't want to do that unless there's tons of stuff around the outside and I can't help it. I really want it to go outside the part. Now in terms of placing that, you don't really have to follow the 1/2 inch rule for the first one. But obviously I don't want it to go really close or way out in space. You can just kind of eyeball 1/2 inch around there. But I've never, at least the company I work for, we didn't really stress about how far out it was. One other thing I'll say about dimensioning too is, in my experience, the first rule that gets broken is the 1/2 inch, 3/8. Well, 3/8 not so much, but that first one being a 1/2 inch away. And let me show you why. So if I do a dimension from here to here, and I track off of here 0.5 up, don't know, okay, there it is, good. And then if I try to place a diameter dimension, and I try to follow the rule of not putting it on the part, so I try to put it on the outside, but there's not a whole lot of room for it. This one's not terrible, but a lot of times you'll see that we'll go ahead and stretch out these other dimensions, because what I really don't want to do is cross the dimension line more than anything. That's the biggest no-no in dimensioning, is crossing a dimension line. Yes, it does, and that goes back to that, make sure it's easy to interpret. Especially again, if I throw in more of a straight line, then it can look like an extension line. So we don't want to cross. And again, if I go back to the other idea of, I definitely don't want to do that either, where I'm crossing over the bigger dimensions. So the smaller one goes first, then the bigger ones. All right. Full scale dimensions, do not edit the dimensions and cheat and just change the value. I'm sure nobody in here would do that, but want to make sure that that doesn't happen. And I'll give you an example where it's okay to put in a dimension that's not exactly right. So sometimes you'll have maybe a very long cylindrical shaft, for example, and I don't want to create a view that just shows, to get it to fit on this paper, to show a little small circle and then be able to fit the full length of this shaft on the paper. And I've got to dimension it. That's not a great looking view. So what I want to do instead is I want to zoom in and I want to get that at a larger scale. So maybe I can get the circle shape a little better, and then on the rectangular shape, the longitudinal view, I am going to break it. So I might have some break symbols like that. If it's a cylinder, you'll often see something like that for a break as well. Hopefully that looks familiar to some of you. And then when I'm dimensioning it, whatever the overall length is, the thing is it can't be measured on this piece of paper, right? So let's just say it was 20 inches. So what we'll do is we'll put a line underneath it to indicate that it's not to scale. And this is one of the only reasons why it makes sense to put a not to scale dimension in there. And then you'll often see a little symbol like that on the dimension line too, to call attention to the fact that it's a broken dimension. But I dimensioned this, it was supposed to be a diameter 5, it's showing me 4.8, so I'm just going to edit the text and change it to diameter 5. Don't do that. That's bad. But you guys knew that, right? Okay, some additional rules, and the book breaks this sometimes, but it typically will tell you not to put in the manufacturing operations, that we let the people actually making it decide that. Now that could be different per company. I'm talking a pure ANSI standard, but each company has their own standards as well, so some companies might want that put in. I just noticed on this little image that there's something actually wrong with that leader, and that is the fact that when you are calling out something that's a circle, that leader should be pointing towards the center of the circle. So as you can see, this would miss the center. It's over to the left a little bit. So when you're just putting in leaders, you kind of eyeball it as best you can. When you use the diameter or the radius tool, it will actually point to it. And that's why a lot of times if I was doing that one, instead of using the leader tool, I would just go ahead and use the diameter tool. and then edit the text and delete it and then put in whatever I needed. Or hopefully if the value was what I wanted, I'd just add the drill to it afterwards, is really what's probably the best thing. So in CAD drafting, we always do capital letters. I know in this day and age that means you're yelling at people when you're doing that in emails and stuff, but we do all capital letters when you're putting in text into your drawings. Okay, mentioned this one earlier, but we don't want to cross dimension lines. Sometimes you have to. Sometimes you have a really complex part and you can't help it. And we have a tool for breaking if that happens. Let me show you that real quick. I don't think you're going to run into this situation, but just for the heck of it, I'll show you this neat little tool that we've got. Let's do a linear. Okay, so bad dimension. I shouldn't do this, but when you get to one that you just can't help it, you've got to cross on the Annotate tab. In the Dimensions section, we've got some additional tools here. Zoom in here so you can see them a little better. And this one right here is my break tool. So I'm going to choose my break looking at my command line, select the dimension you want to add a break to. So I want to add a break to this one. Now select the object you want to use to break it. Now it'd be this dimension. And as you can see, that puts a little break there. It's pretty cool because it updates. If I move this dimension over to here, it continues to break. If, for the sake of argument, it went through the text, it would break around the text. So it's kind of neat how it updates. And the other thing is it's still an associative dimension. So I didn't lose that associativity. In my day, because I'm so old, I used to have to explode these and then literally trim this out. And then if something changed, guess what? I got to redimension. So pretty cool tool. Like I said, some of our stuff, especially here at the beginning, is pretty simple, so I don't think you'll need to do any breaking, but just wanted you to see that that tool is there. All right. The other thing I want to mention too is you want to place your dimensions between the views when possible and when it makes sense. And so this is why on some of those drawings I had you do, we scaled them in such a way that there was plenty of space around them because I want you to be able to fit your dimensions in between the views. So I did not give you guys required spacing between the views. So if you find that you need to move views apart in order to fit things, just remember that you want to move them uniformly. So if I spread out maybe 1 inch between these two views, these need to spread out 1 inch as well so they continue to project around. But put dimensions between views where possible, but also where it makes sense. So if I'm dimensioning, you know, these shapes here, you saw me do that already. I keep pulling them to the middle. When I'm dimensioning this part over here, I'm putting things between views, and again, I'm just doing this quickly, so I'm not really spacing. I got this little notch over here. It really doesn't make a whole lot of sense to pull it across the part and put it on this side. It's going to be a nicer looking dimension over here on the side. So where it's possible, which usually we can make it possible, where it makes sense too. So I wouldn't want to pull, you know, this one up here either, when it probably makes a better dimension down here. And again, a lot of these things are subject to company standards as well. There might be a company that says, no way, don't ever put them out there. Go ahead and cross the part. In terms of the text, they should be about 1/8 inch tall. That's again controlled by your dimension style, so you shouldn't have to do anything about it. Titles, if you're putting in notes, 1/4 inch tall. You can use center lines as extension lines. So for example, if I had some center lines drawn on these shapes, which I don't yet, and you can also see that the dimension style puts those in too. But let's go to annotate. So if you want to put in a center line, you can go to annotate, the dimensions drop down, and then the center mark tool. And then I can click to place the center mark. So then when I'm dimensioning, I do not want to leave the gap this time. I'm actually going to make sure that there is no gap. Now, wrong layer, so I'm going to switch that into the correct layer. But see how the the extension line and the center line just blend into each other? if I look at the layer properties manager, the center, looks like there's slightly different widths in this particular template, but I don't think it'll be perceptible on the paper. It'll just look like one continuous line. And this is the other reason why when we print, we use the monochrome style, which should be set up automatically in your template. This is kind of an old drawing, so I didn't have it set up in here. But that way everything prints black and you don't have different shades when you're printing. All right. Dimension to the longitudinal view of a positive cylinder. So I mentioned earlier that I could tell that something was a hole and not a positive cylinder. So a positive cylinder just means a cylinder basically. It's an actual solid object. So if this is a hole, then you are going to dimension it with the diameter tool. And again, I thought I had changed my layer, but I guess it didn't. So I'll put that in the right layer. So that is the proper way to dimension that feature. Now if I have, and I'll just do this in model space for now. If I have a circular shape, so it's a cylinder, and I want to call out its diameter, a lot of people want to just call out this circle. But the proper way to dimension it is, if it's a positive solid cylinder, you dimension the longitudinal view, which means this view right here. And ½ inch out. I don't think it actually went ½ inch that time. Oh, you know what? I'm in paper space. I mean model space, so it might have. Yeah, it did. I'll talk about that more in just a second. So in this case then, what I want to do is I want to double click on the text, and you can see the blinker in front of it. You can use your arrow keys to go after it or before it. And then I'm going to go up to the symbol tool, and then I'm going to choose the diameter. You can also type %C to get the diameter symbol. So that would be the appropriate way to call out a positive cylinder, and I'm going to need to space it out a little more there. I don't think you have any of those today anyways, but it is something that's going to come up. And then again, the circular view of a negative, a hole. We talked about omitting one in a chain, and we talked about using the dimension tool diameter on full circles and radius on arcs, and then going to their center lines for their locations. So here's an example of some positive cylinders and how they should be called out. We still include this view to show the circular shapes, just to have a better understanding of the part, even though we don't actually have any dimensions on it. Notice also removing one in a chain to avoid the tolerance issue. And again, negative circles or holes, you can see we call those out in their circular shape, but positive, we call them out in their longitudinal. These rounded slots and parts, we'll talk about those a little bit more later. I'm going to hop over them right now. Same thing with slots. So this one's just given a step-by-step of just the thought process, calling, find something, call it out, call out all the shapes, and again, you can see they're going in between the views. Notice something like this. Again, we talk about chain and leaving out a dimension, but also try to include overall dimensions. So that way I know that this part starts as a 60 by 60 by 40 millimeter part, because that's typically going to be the first cut, is the overall shape. And then we can start notching things out. Now, would it matter if I included this one or this one? Again, I don't know. It probably depends on the cutting process. So if this is put on a table and then it's measured over and then cut, this one probably makes more sense. So I want to talk about a couple other things in AutoCAD here. I am still using my old school dimension tools, which are located in this little drop-down list. We also have this fancy new dimension tool that's brand new in AutoCAD 2016, and it's made to be an all-in-one dimension tool. So if you've used Inventor or Creo and there's like one dimension tool, that's the intention of this one. It works fairly well. I'm still kind of stuck in my old ways, so I haven't played with it a whole lot, so I'm going to show you that a little bit. The other thing I want to point out too is that I want your dimensions to go in paper space. So I'll remind you of what that means. Let me see if I have any scaled differently. I think these are all 1-to-1. Give me just a second here. I want to open up something that was 1-to-2 if I can find one. Actually, those will work. 759 dovetail bracket. Give me a second while my slow AutoCAD hopefully opens up. There we go. Okay. B-size layout. And set to 1-to-2. Good. Okay, so let me go back to one of these other ones here first. So every time I dimension, I'm putting the dimensions in paper space. So that means I'm on the sheet of paper here. I've set my viewport scale. I would also strongly recommend that you lock it as well so that you don't accidentally pan and move things around. And right now I'm still in the viewport, so any dimensions that I add will be added to the model itself. So if I go back to the model space tab, I can see that dimension I just placed in there. So I'd prefer you not dimension that way. I'd prefer it to be on the paper. So I'll just double click outside the viewport or use the paper model button down at the bottom. I can see it says paper. So now all dimensions that I'm placing are on the paper, not in the model itself. So one of the reasons why I recommend you dimension that way is because it's always going to be correct. Your text heights are always going to be the right size, your arrows, etc. Is all going to be full scale on this piece of paper. The truth is, on this one, since it's a full scale drawing, if I dimension one on the paper and one in the model side by side, you aren't even going to notice the difference. They're the same size. But when I go to a drawing of a different scale that's not 1-to-1, like this dovetail bracket, then you're really going to see the difference. So on the paper, I dimension it. That's the correct dimension height. If I do it in the paper, or in the model, excuse me, and make the same dimension, oh, you know what? There is a separate thing that actually helps me on this that's called annotative scaling, and actually calculates the scale for me. So that's good news too, and you'd probably still be okay if you did it in model space. I think I set the annotative scaling up on all the templates, but the annotative scaling basically looks at your viewport scale and applies that scale for you automatically. Let me give you an example of one that doesn't do it since I brought it up. I'll choose standard. So see the little symbol next to the dimension styles? This indicates they're annotative, that it'll scale automatically for you. But let me use the standard one here and do the same thing. Now you can see that the text height is not correct. It's actually too small. And I can't remember if I set the default templates up to use annotative or not. But the good news is you keep it on the paper, it doesn't matter. It's all going to be right. You won't have that issue. And then this fancy new dimension tool, I'll show you a few of the things that it does. B-size, there we go. So this dimension tool, instead of using just the linear one, it works great for creating linear dimensions. You can see it kind of previews a little bit differently. Let me make sure I've got my dimension layer set. So that'll work. I should still be able to track 0.5 off. That all works great. I can use the same dimension tool on an arc, and it recognizes it's an arc and should use a radius dimension. I'll use the same tool on a circle. It recognizes its diameter. So it's a pretty smart little tool. It has some other little tools built into it. You'll also see sometimes, if you take a look at this dimension right here, how it put these leaders in here or these center lines in here, and it's interrupting my text. If you run into something like that, you could explode it and delete this line. So I could explode the dimension and delete. The only problem there is this is no longer an associative dimension. So if this changes, that one doesn't go with it. So the other thing you can do is, oops, I didn't undo far enough. There you go. Go to Properties, right click and go to Properties, and then you can override the dimension style for this one. So center mark is set to line. I can just change it to mark. And you can see now that it just gives me the little mark in there. You could also set it to none too if you've already done it with some center lines. But feel free to explore that new dimension tool or use the existing ones, whatever you feel more comfortable about. The only problem I've had is sometimes with this dimension tool, it gives me an aligned instead of a linear, and it's a little touchy. So see, it's giving me the aligned, but if I hold it just right, it'll give me the linear. But sometimes it's kind of jumpy, and that's usually when I'll just say forget it and go use the one that I want. But feel free to explore that. Check it out. Okay, so here's the plan for today. In your textbooks, I'm going to have you draw up a couple of fairly simple drawings and then dimension them. And let's see, 6, 9. Okay. They're on page 123. And this one that I've been using as an example, the rod support is one of them, $6.99. And then the one down here on the bottom, the rocker arm, 6-101 is the other one. So I'd like you to create the 3 views and then fully dimension them. They're both 1-to-1. In addition to that, because they're not that complex of parts, once you're done with that, you are going to revisit some of the parts you've already drawn, and you're going to dimension those up as well. So the 2 drawings on page 123, and then open up these other 4 drawings that you've already created, and then add all the dimensioning in. Now keep in mind the book gives you an isometric drawing. They're just giving you enough values to draw the stuff up. They're not necessarily dimensioning it properly. So we want to adhere to those rules of dimensioning. So feel free to take a break at any time and then let me know if you have any questions.